So the goal now is to introduce another example, and this example will be a to-do list. So a to-do list maintaining tasks, different tasks that someone has to do. Now this to-do list, this example is meant to really illustrate magic methods. So if you haven't watched the introduction to magic methods yet, do that, and at some point in that video I will send you back to the examples. So you should come back, watch this example then, and then go back to the end of the magic methods explanation. In any case, this is my directory that contains 3 different files, main, task, and to-do. And those are here on the left, of course. And you see here a task object that is pretty much completely understandable to you guys right now. It doesn't do anything much different from person, for instance, before. So if I run it, I can say that from task, I can import task. And I can call task for some tasks. So teach week 9, let's say. And this is for me. Okay. So I can create a new task. And this is done here with init, which is a magic method. And you see that this takes 2 arguments, name and owner, and this is what I used here. And what does it do? Well, it will keep the local dictionary of the instance, so of new task, and update it with the local dictionary. So what it's really doing is assigning the key name to name and the key owner to owner. So it's as if I had done here self.name equals name, self.owner equals owner. It's just a shorthand to do that. That is good to know. But it also keeps track of what time it is now, at the moment where the task is tasked. So if I take new task and ask for name, you will see that that's the name of the task. For the owner, that's the owner. And for the time where it was submitted, you will see the internal date time format. So November 8th at 5:32, at 5 o'clock with 32 seconds. Okay, so you see that on Friday night I am doing my video for teaching on Monday morning. So it's quite a tight rope here. In any case, this is accessing the data attributes directly, but I can also print new task, and this will basically print all this. And so you see that the task was assigned, and it's assigned 80 seconds ago. And this will change actually. And the way this is done is by using a method called elapsed seconds. And elapsed seconds, only this case is relevant right now, will compare the time where it's called to the time that was stored as the time of submission of the task, and tell how many seconds that is. So I'm using total seconds, which is part of the date time module. Anyway, it tells you how many seconds have elapsed since I tasked teach week 9. Elapsed seconds takes an argument, an optional argument compared to, an optional positional argument compared to, which will become relevant later, but it's basically, you can specify when to compare to. So do you want to compare to the time of submission, or do you want to compare to to right now? Do you want to compare to right now, or do you want to compare to another time? So this will be relevant when we look at the to-do list, which we're doing now. So again, if you haven't looked at the introduction for magic methods, go do that now, because things will make much more sense then. So we import this to-do list. So from to-do, I import to-do. And I define a to-do list to be basically mine. So if you look at the to-do constructor, this uses just one argument, which is owner. So this prints creating an empty list, which you saw here, and then it saves the owner, and then it saves the tasks as a list. So this is a decision we've made here, and we'll see that we will come to regret it later. Okay, so what good does that do? Well, immediately one of the one of the magic methods that is defined is str. And you see that str will do quite complicated things to make sure that everything is done right. But in this case, if I do print my to-do, it says that Paul now has no task because I have no task. If I had a task, the message would be substantially different. And we'll see this in a second. Okay, so this is the str magic method. Here are a few other ones. So length will return basically just the length of the tasks. So I can ask directly for my to-do, and it has a length of 0. So make sure you understand what's going on here. This here is an object, but it's not a list, and I'm calling the length. And this length here, this function, is tied, it's a shortcut for a Python magic method called double_length double_. And this will return the length of the tasks lists. Okay, so this is a shortcut this is a definition that allows me to use this shortcut later and improve on my code, make my code shorter. So maybe you don't really see the point of that. I mean, I could just write that everywhere instead of writing length of self, right? But here is another advantage. If you define an iter magic method, this creates, if you do it right, this will create an iterable over the tasks in the to-do list. And this is the point here. I'll explain this more in detail next week. But I can then iterate over all the tasks. So before I can show you this, I need to add some tasks to the to-do list. And for this, I'll use a push and complete. So let's first push something to my to-do list. And the first thing I'll push is kill that jumping icon that is annoying me. And I just added that task to my pile. And okay, here is how you can really understand what a to-do list is. In this case, I have put the condition that is the condition associated. I've put the condition that the to-do list has to be. I have to always take the oldest task and complete that first before I can complete another task. So it's first in, first out. So here at the moment, I have in my to-do list my to-do. Okay, if I print my to-do, I have that Paul now has one task for a total wait time of 43 seconds, and the task is kill that jumping icon, and it's assigned to me. Okay, so but I can also push there teach week 9. And I've added that task, and now I have 2 tasks in that pile. So if I print my to-do, I see that I have now 2 tasks, kill that jumping icon, and teach week 9. And okay, but I don't have to just push things, I can also complete things. So you see here that complete removes the task as it gets completed, but it will take the task lists and pop the initial one, and then print completed a task. So ignore the comments here for the moment. I'll explain them at the end. So this is how you do it. So my to-do dot complete would complete the first task in my list, which is kill that jumping icon. Well, I haven't done that yet, so let's kill that jumping icon. No, I don't want to update. And then now I have completed the task. So Paul completed a task, and then it says which task I completed. Oh, and it returns it, sorry. So this, it would have returned it, and that's why it's printed here. Okay, so now I have my to-do list is an object, and then I have print my to-do, and those are all the tasks. All right, so this explains push and complete, and I would like to have many more tasks to be able to to do things. So I will push here, look at the projects. So I have to look at your projects, and I have to upload new material for week 9, and so on. So if I print my to-do, you see that I have several tasks here. Now the nice thing is, thanks to iter, and we are getting back to that now, I can do some neat tricks. So I can do for task in my to-do, I can print task. And you see that this works. I'm printing every task here nicely. So the fact that this works is because my to-do is an iterable, and this is happening here. And I said I would explain that later. Okay, so I can also get specific items, and for this I need a key, and then I need to get that item. So I can ask for task 2. And for my to-do 2, and this gives me a task, and I can print it. So this is upload new material, and I can also check that some task is inside the to-do list, and I've decided that my interface here, I'm not doing it this way, I'm not doing it that way. This does not work. I'm checking if the name, so upload stuff, is in the name of any of the tasks. And so this is checked, and this is not true. And I can also do this. So, and this will return true because I've decided that this should return true if the cases don't match. So I'm lowering everything. So you see that this in here is the shortcut for contains. Okay, so this might seem very weird, but I'll explain that later on in the more detailed explanation of magic methods. Okay, so this is get item. This is getting the second item in my to-do. And so you might think, okay, great. So this means I can assign some new task, like upload a video to YouTube, to my to-do. But this is not true, but because I need to use push, okay, instead. I don't want this to work, so I haven't defined set item, or actually I've defined it to return this error message here that you see there. So you see that depending on how we use this little square bracket as inside a print statement or on the left of an assignment, different things will happen. And Python is smart about it, knows what it should do with all those things, and looks whether you have defined the relevant function, and if you haven't, figures out what to do by default. But if you have, you can add very, very interesting behavior in the right places. Okay, so one more method I want to tell you about is the total weight method. So this is my to-do. My to-do, and I can call total weight. And total weight will tell me that I have waited so far on all my tasks 785 seconds for all of them together. And you see that the code is actually very readable. I do two different things. If some argument compared to is specified, then I'm comparing the total weight compared to that moment. But it's not specified. So I go here, and then I save now, and then I call the total sum of the elapsed times, the elapsed seconds for all the tasks. And you see that some part of this are enabled by defining different magic methods before. So this very nice thing for task in self, that's enabled because I've defined iter before. That I can iterate over self and not just over self.tasks. Why do I do it this way? Why do I pass an argument now? Well, the reason is that I would like, as the computation is happening, time is passing by as well. So I think the only reasonable thing in this case is to save the time and then do the computation for the time that has elapsed. Right? Imagine that the task list is very long, then depending on how this is computed, this would have absolutely no meaning. Total weight. Okay, and this is all great, but then you can also do comparisons between to-do lists, and this works by implementing a CMP function, and this CMP function basically has to return a negative number, a 0 or plus. That's how that works, and a negative number if self is smaller than other, and a positive number if self is greater than other, and 0 if self are equal to other. What I mean here is that if I have two to-do lists, I can do things like this. And I can compare the two to-do lists and see whether they should be equal or not. And this is done with CMP. And so CMP would be called for my to-do and then my to-do too, and would be computed. Now, how will I decide? Because those are calculated to the 100th of a second. Well, I decide in this particular case that there is a tolerance of 1 second and that the total weight should be used. So I will again save the time now and compare the time that has elapsed for the two different to-do lists with respect to now. And then I will compute the difference. And if that difference is less than 1 second, then I return 0, meaning the two are equal. And if not, then I return the difference. So meaning I return plus or minus, and this will decide whether one should be less or equal or greater or equal. Okay, so maybe I give some examples here. So if I, maybe first I discuss here at the bottom why this was inefficient and why we're still happy that we did it this way. This is inefficient for two reasons. The first one is here. When I complete a new task, I have to go in when I complete a task, I have to take my list self.tasks and remove the very first entry. Now, this is inefficient for lists. This is how you do it, but this is not the most efficient for lists. If you have a very long list, it will need to move around in memory a lot, and that's not good. So you don't want to do it that way. So the other thing is that if you take the total weight and if you look at contains, the code for it requires that we go through every element of the list and check that any of them are equal. And any I didn't talk about, actually, any returns true if it's true for any of the entries there, and otherwise returns false. And the advantage is that it stops at the point where any of them is equal to true. Anyway, I have to access every task in order and compare it to task name. So that's not very efficient, and again, you will see later why. It might be much better to use a dictionary here, and for this problem here, it might be much better to use a queue structure. And again, we'll see that later. So there are different solutions. We could use a dict I just mentioned, or we could use a queue, or we can use some combination that would deal with all those problems. It really depends on how we intend to use the to-do list and what kind of operations we intend to do a lot. And if we very rarely intend to complete tasks, then we're fine. For one of the two problems, although it's kind of, you have to look at the use cases. But as I say here, there is one very important fact to understand. If we have built code that relies on this to-do list, and we decide that it's inefficient because of one of the problems I mentioned, we know exactly where we need to do a change. We need to do a change here in using a list to store the tasks, and in a few other places in this file, and nowhere else. we don't need to do a change in any of the files that use a task, a to-do list. And that's very important. That makes code very maintainable, very not efficient, but very efficient for the writing of the code. So very efficient for the humans to produce that code. Okay, in any case, I promised some examples of use cases. So here it is. So I'll import main, and all kinds of things should happen. So here I've decided to look at to-do lists for a math student and Harry Potter. I'm sorry, I went a bit crazy. So I create two to-do lists, one for the math student, one for Harry Potter, and I push different kind of tasks. So for the student, figure out how to run Python. Hopefully this has been done a long time ago. For Harry, put glasses on. Same thing, done a long time ago. Learn to ride a broom, and then I'll wait 0.5 seconds. And the student has to learn Python, and then it prints the current status. So the current status is that Harry Potter has 2 tasks for total wait time of 1 second at the time, right? Because each of those were introduced, and then we waited 0.5 seconds, so this makes a total of 1 second. And the math student now has 2 tasks for a total wait time of 0.5, because one of the 2 tasks was added after waiting. So do they have the same amount of work? Well, it's true, and this is obtained with the equal here that uses CMP that was defined, because the two to-do lists are within 1 second of each other. Then I decide to wait 1 more second. I'm done waiting, and Harry completes a task, and then I print that task. So Harry completed a task, and Harry completed the task, put glasses on. Now I add a bunch more tasks to Harry, and it's very easy to understand what those tasks are, thanks to the interface that makes this completely transparent. And I print the status again, and then I check whether it's greater or equal. So this will use CMP behind the scenes, the CMP that I defined, and the current status. You see that the student has at least as much work as Harry Potter. And I add one more, and this is basically what will make tip the balance. Basically, the student has to study analysis, while all Harry has to do is defeat Voldemort, and so that's it. The student has much more work than Harry Potter, as is advertised here. Does the student have strictly more work? And this is seen to be true. Now, just a few more things. I can check once more if a specific task is in Harry tasks. And yes, it is. Harry still needs to learn to play Quidditch. And you see that I didn't enter it quite as it was entered originally, but because of my smart contains function, this was dealt correctly. And at index 2, the student has this task. So at student 2, the student has the task to study linear algebra. And then I try to access a task and insert something that's not really essential, like do laundry maybe. And you try to add the task do laundry at position 0, but that's not how to do it. You should use the push method. So we've seen this before. So I went a bit overboard with this example, but I hope that by anchoring it in relatively simple things conceptually, you understood classes more easily, and you will be able to use them to great effect for your projects.